Okay, so starting on 11.5 notes, you'll see this section. This is actually review over 11.4. You'll need to be able to name and identify figures on your quiz, if you haven't already taken it. We're going to match the figure with its name. Some words will be used more than once. I'm actually just going to go in ABC order and then see if it's a cube, triangular prism, rectangular prism, pyramid, or cylinder. So this first one, we see that there are circles. You can identify that. So because there are circles, this can either be a prism or a pyramid. So it's definitely not a prism, definitely not a prism, definitely not a pyramid, definitely not a pyramid. Not technically. So hopefully, a cube, it's definitely not a cube. A cube is a type of prism. So the only other option is a cylinder. Hopefully you would have already known that it was a cylinder. Most of us have seen cans of soup. A can of soup is a cylinder. We'll move on to letter B. So we got that one taken care of. B. So all of the edges are straight. So it's going to be either a prism or a pyramid. So students get this one wrong, only because the difference between a prism and a pyramid. A prism, and we'll talk about it today, a prism will have two congruent and parallel bases. If you don't know that, I would write that in. A pyramid, let's see where I have room. A pyramid will have one base, and it will be a cross from the vertex. Okay, so we'll talk about it. This one, you want to see if you have two identical and congruent bases. So keep in mind that bases aren't necessarily on the bottom, because if we were looking at this, the bottom of this shape, the bottom is a rectangle, and there isn't a parallel rectangle. So that's not the base we're talking about. Here, the base would actually be triangular. Here's one triangle, and then here's a second triangle. So there's two bases, they're congruent and parallel. So this is a prism. And because the bases were triangles, this is actually a triangular prism. It's not a pyramid because a triangular pyramid would have a triangular base, and then all of the vertices would come together at one point. So you would have a vertex, and then you would have one base, whereas this had two bases, and then it didn't come together at one point. So that made it a prism. So we got that one. C. So C, we have one base. So the reason that this is my base, let's look at the triangles. In order for it to be a prism, they have to be congruent and parallel. If you remember what parallel means, that means two things that'll never intersect. They move infinitely side by side, and they will never touch. If you look at our pyramid, let's say this front portion, I'll color it better. Let's say this front portion we were investigating to see if it was the base. It is across from this back triangle, but they are not parallel because they touch at the vertex at the top. So this is a pyramid. Definitely a pyramid. Obviously we've all seen like the Sphinx and whatnot. No. Well, the pyramids in Egypt. I don't know why I said Sphinx, because life. But this is obviously a pyramid, so you want to look across from the vertex where they all come together, and then across from that is going to be your base. So the base's shape is a rectangle, so this is a rectangular pyramid. So that's C. D is a prism, but it's a specific type of prism. Hopefully, maybe if you've seen, a tesseract or a Rubik's Cube or a cubicle, I don't know, you would be able to identify this is just a cube. Reason being, any of these could be called our base. We have a square, they're opposite and congruent and parallel, square and a square, the same thing with the front and the back. We'll move on to E, E over here. So this one looks more like a moving box, where you could really pick any of these as a base. Again, the base does not have to be on the bottom. If you looked at the bottom, a lot of people would think that this is a square, but there's a square prism doesn't exist. A square prism would technically be a cube. So, I'm going to choose my base to be the sides, because why not? They're opposite, they're parallel, they're rectangles, so this is also a rectangular prism. A rectangular prism is the only prism that it doesn't matter which of the two sides you're looking at to call a base, because literally all of them are rectangles. If you had chosen the front, this is a rectangle, the back is a rectangle, it doesn't matter. It's a rectangular prism. Basically, if it looks like a tissue box, a moving box, literally any type of box. Letter F, same thing. It is a rectangular prism. G, so you would probably notice right off the bat that you have two triangles. So again, this poses the question, is it a triangular prism or triangular pyramid? So prism, you would have, prism has two bases, and a pyramid has one. So this one has two bases. This would be a triangular prism. I'm sorry, y'all, I didn't read correctly. This is a triangular prism. If you're like, Miss Marshall, why in the world was C a prism? It wasn't. I just apparently can't read. I can. I'm sorry. This is a pyramid. Hopefully you don't hate me right now. I kind of hate me, so sorry. So it's a rectangle. It comes to one point. It's definitely a pyramid. I said it. I just didn't read. Last one would be H. So again, we would all see this triangle. It is the only triangle. There isn't a parallel triangle up here to make it a prism. And then all of the sides come together at a vertex, which makes it a pyramid. A pyramid. Again, sorry for the mistake. We're going to talk about volume of prisms and pyramids. So volume is a real-life skill. Let's say you are trying to figure out how much water to put inside of a pool. Volume is how much fits inside of an object. So again, water in a pool, air inside of a basketball. You like my basketball? I mean, how many toys fit in a toy bin, whatever. You name it. It's how much fits inside of an object. So we're going to figure this out. If you're planning on doing like a carpentry trade or something like that, this is a topic it'll become old hat. So let's go ahead and get on in it. So to define a prism is a solid geometric figure whose two end faces are similar, equal, and parallel figures. So in our first, we've got a Kleenex box. You can probably figure out what kind of prism. You could look at the bottom. You could look at the bottom, and obviously we can't see all of the bottom, but it's a rectangle, and the top is congruent and parallel, which means that the top and the bottom would never touch. So that could be the base of a rectangular prism. The side and the side could be the base of this rectangular prism. And then the front and the back, again, rectangle, and then the back is an identical rectangle. We're going to talk about Toblerone. Apparently it's some type of toffee. Some people like it. It's not my jam, but whatever. This is a prism. If you notice this triangle, if you've ever seen a Toblerone, I don't know. I think they're at Cracker Barrel. You can buy them in the little shop area. but they have two triangular bases. They are congruent and parallel, so they'll never intersect. They're connected by, you know, these lines over here. So that's a triangular prism. And then your classic cheese. If you've ever seen Tom and Jerry, I don't know if this generation knows what that is, but if you do, there's the cheese, and it's a triangle. The top is a triangular shape, and the bottom is a congruent and parallel triangle. So it's also a triangular prism. Knowing what kind of prism is very important, or if you don't identify it correctly, you won't find the correct volume. So the formula you want to write down to find the volume of any prism is the area of the base times the height. And I'm actually going to have you write height of the entire object. And I'll explain why you write that. I would highlight this. I would, you know, make it very easy for you to find, because this is crucial for this section, but also 11.6 piggybacks kind of right off of prisms. We're going to learn about pyramids. So basically where this comes from, we learned about cross sections in 11.4, and it basically looked like this little sheet of paper that was highlighted in an object. So what this formula is saying, if you found the area of a cross section and then multiplied it times the height, you would find how much fits inside of the object. Because if you really think about it, the height represents how many little cross sections there are in this object. So that's where this formula comes in, if that makes sense. So envision, like, I don't know, however many sheets of paper stacking up inside of this object. And that's how volume is figured out. And then something else to remember is that you're going to answer in cubic whatever. So what that means, it would be like inches cubed, yards cubed, you know, centimeters cubed. The reason being, so area, you remember area. Area is two-dimensional, right? 2D, two-dimensional. So we always answer inches squared, yards squared. You're figuring out how many little square inches or square yards or whatever fit inside of the object. Whereas here, we're finding out how many cubes, because remember, cubes are 3D, you know, squares. How many little cubes can fit inside of this object? So we would say cubed units. So yards cubed, meters cubed, miles cubed, things like that. Other important things to note, there will only be two bases. So only two bases. So this will help you decipher between a pyramid and a prism. Because let's say we had a rectangular pyramid. Some people, it's not going to be beautiful, just accept it. Some people would think, well, I see a triangle, so this has to be a triangular prism. But there's, you know, one triangle over here, there's a triangle over here, there's a triangle on the back. Does that make sense? So there wouldn't be only two bases. So two bases, they will be across from each other. So they'll be across from each other. Sorry, I'm finding a... Or you could say opposite if you want to say opposite, or if you want to say across, it doesn't matter. They're going to be opposite, they're going to be parallel, and they're going to be congruent. Okay, so opposite, parallel, and congruent. And then the last thing, when I say the height of the entire object, sometimes the height will not be up and down. So think back to like the Toblerone on the page before. We had a triangle and a triangle. This is not going to be beautiful. It is what it is. Most people would assume that the height would be in the triangle, but it's actually not going to be that. The height, just going to move this, the height is going to be what pushes your two bases apart. So the height in the Toblerone would actually be here. this would be the height of the entire object. It pushes the two bases apart. Or like here, I drew two congruent trapezoids. Beautiful. So since there are two trapezoids, the trapezoids would be the base, and the height would be what pushes your two trapezoids apart. Okay. In the pictures that they gave us, they represented the height as the up and down. So what they are saying is this is the base and the bottom is a base. Base, base. So height can be up and down, or it can be side to side. So the 4 steps to finding the volume of prisms. This is the one that I prefer. It helps me out visualize. Highlight the base's shape. The rectangle, the square, the trapezoid, and then a triangle, whatever it is. It's got to be, there's 2 of them, and they have to be parallel. So it kind of helps you figure out what kind of prism you're looking at. Once you highlight it, I would then find the area, and I'll refresh you the area formulas, but you're going to go off to the side and find the area so that you can plug it into the volume formula. And then the main thing to remember, or to really know, not a lot of students, but the most common mistake that I see is that students just try to look for a number and then plug it in for the area of the base. Or they just look at the base. Like let's say we had this picture, I just drew this. They would see, oh, here's a 6. That must be the area of the base. But it's not. It's the length of something. So the area of the base you're going to have to actually find using an area formula. So make sure that you go off to the side and find that area. Once you've plugged that in, you're going to find the height. Again, the height is what pushes apart your two bases. So if you see in my picture that I literally just drew, how I drew it, I drew a rectangle, I drew a rectangle. These would be my bases, and the height is what pushes them apart. So there's that. So you would multiply by the height of the entire object, okay? And then answer in cubic units. So our first example is we're going to find the volume of each prism. So the first thing that we want to do is identify this prism. We're going to highlight, ooh, that's not an I. We're going to highlight the bases. So again, the bases are going to be congruent and parallel. So most people would see this rectangle. You need to ask yourself, does it have a parallel rectangle to it? So it would be opposite of it. It would be either behind or in front. And parallel means they wouldn't touch. So you see there's a rectangle over here. They do touch. These are not parallel. They touch in this corner. So the rectangle is not the base. It's not the like the literal shape. You would see that these are two triangles. So this is a triangular prism. So the next step is step 2. We are going to find the area of the base. Okay, because remember, the volume formula, I'm going to write AOB for area of the base. It is the area of the base times the height of the whole object. So the area of the base, so I'm going to find the area. It is a triangle, so this is where you would need to know the triangle area formula. I can put it at the end of this lesson. The area of a triangle is 1/2 base times the height. So if you notice this is a right triangle, because remember the top and the bottom, there's my right angle, the top and the bottom are congruent and parallel. So if the bottom is a right triangle, the top is a right triangle. And then what you need to remember about triangles is that the hypotenuse, we have talked about this before, the hypotenuse is never the base or the height. I would write that down so that you, if you're given too much information, that you know which side not to use. So the hypotenuse is never the base or the height. So luckily, they gave us, I'm going to erase a little bit. We're only looking at the triangle. luckily, the hypotenuse, they didn't give us the measurement of that. So we got a base. We could call 3 the base and the height be 4. It doesn't really matter because you're multiplying. So the base is 3 and the height is 4. It doesn't matter what order you multiply in. I'm going to multiply 3 and 4, which makes 12. Half of 12 is 6. So that means the area of the base is 6. And then the height of the whole object pushes apart the two triangles. So you would want to look at what pushes apart each of the vertices, and it's going to be 2. So 6 times 2 is 12, and then we're going to answer in cubic units. I kind of skipped the third and fourth step. Third step is to multiply by the height, is on the last page. Multiply by the height and then answer in cubic units. So this would be centimeters cubed. So that means you could fit 12 small or centimeter cubes inside of this object. The second is very funky looking. You'd actually see these more like a jump box. If you've ever, maybe you haven't done a jump box. I don't know. I don't know how to draw one. Not even gonna try. Basically, if this were turned upward, I guess. After failing at drawing it, I just found one on the internet. A jump box, you use it in sports. But if you look, this is a trapezoid, right? And then it has the opposite side is congruent and parallel. So a trapezoidal prism, if you've ever been in our gym specifically, we actually own some. So anyways, this is a trapezoid because a trapezoidal prism, however you want to say that. None of these squares have a parallel square to it. These two aren't parallel. If they kept going, they would collide. So the congruent and parallel bases are trapezoids. Again, if you don't remember the formula, volume is area of the base times the height of the whole object. So we're going to need to find the area of the base, which we've already established is a trapezoid. It's not one that you do often, so I understand if you don't remember it. It is 1/2 base 1 plus base 2 times the height. So I am going to signify this height is of the trapezoid, and the height in our volume formula is of the entire object. The height of the entire object is what makes it 3D. So what makes it three-dimensional? Okay, so we're going to look at the trapezoid, and I'll show you the difference between the height of the trapezoid and the height of the whole prism. So B1 and B2, it looks hard, but this means the two bases of the trapezoid, these two are going to be parallel. Because if you remember, a trapezoid is a quadrilateral with two parallel sides. So there's that. So you're going to find the two parallel sides, and they are the bases. So the parallel sides would be here and here. So one of them is 14. So 14. And the other is not labeled, but remember the top and the bottom, the two bases are congruent and parallel. So if the bottom is 6 centimeters, that means this top, it's also 6 centimeters. So the other base is 6. And then the height of the trapezoid is what pushes, so this height, or what separates, if you want to call it that, what separates your two bases. So my base is 6 and my base is 14, so what pushes those apart is 3. So times 3. You want to do PEMDAS, so parentheses first. I'm going to move this a little bit. Parentheses first, so 14 and 6 make 20. And then times 3. Again, it doesn't really matter what order you multiply in. We could do 20 times 3, which is 60. And then half of 60 is 30. So that means the area of your base is 30. So area of the base, 30. And then we're going to multiply it times the height of the entire object. So the height of the whole object is going to be what pushes your two trapezoids apart. So here's trapezoid, the top of the trapezoid, and the bottom trapezoid. So what pushes these two apart, these two apart, these two apart, and these apart. So if you look, this 5 centimeters represents from here to here. So your height is 5. Your volume is 150 centimeters cubed. We're going to do the same thing here. Find the volume. I'm going to have to speed up a smidge so that we can get to everything. Volume equals the area of the base times the height of the whole object. So first thing you want to do is highlight the base. This is a triangular prism. So we're going to find the area of the base. Area of a triangle is still 1/2 base times the height. So the base of the triangle is all we're looking at. The base here would be the bottom, which is 6. So that's your base. And then the height of the triangle. So height of the triangle is 4. Again, doesn't matter what order you multiply in. 6 times 4 is 24. Half of 24 is 12. So area of the base is 12. And then again, the height is of the entire object. So what makes it 3D? What pushes apart your two bases? So the distance between the two bases is 9, which makes 108 centimeters cubed. That brings us to cylinders. Cylinders are technically, so if we're talking technically, they are not prisms. But it's the same formula. So volume, so think of it, prisms have two bases, two congruent parallel bases. A cylinder has two congruent and parallel circles. Okay, so that's why it's technically not a prism, because prisms are made up of straight lines, right? No curves. But cylinders fall under the same category, same formula. So I'm going to keep using this. Your book is just going to have you do pi r squared h. I just don't like you to have one more thing to remember. But when I do it in our notes, I'm going to do area of the base times the height. So the bases here of a cylinder are circles. To find the area of that base, you're going to use the area formula for a circle, which you learned about last week, I think. Or relearned, because it's not really new. So pi times the radius squared. Here the radius is 9. So pi times 9 squared. We talked about this last week. Your textbook probably, or the website will use the pi button. So for that sake, I'll probably just use the pi button right now. So for our area of the base, I just typed in pi times 81, which is 254.4, I'm going to say 69, because after that it's 0, 0. And then the height is still of the whole object. The height is what pushes the two circles apart. So here it is going to be 6 feet. So I'm going to multiply times 6. I'm not sure what the website's going to say rounding wise. I'm going to round to the 100th. So 2 decimal places is the 100th. And then still feet cubed. The second, this one is a slanted cylinder, but it's the same idea. Find the area of the base. So my bases are circles. Pi r squared. The radius is 4. So 4 squared is 16. So I'm going to multiply that. So we get 50.265. And then the height, if you see off to the side, it's showing you a right angle. Think about when you go to the doctor's office and they make you stand straight up to measure your height. This is just saying from the bottom, from the ground to the top of the cylinder is 7 centimeters. So that is your height. It's representing your height. And then we're going to multiply that, round to the nearest. We're going to do 100th again. So 351.86, and it is centimeters cubed. I promise we're almost finished. We're actually not going to do, oops, sorry, I was trying to draw an X. If you have this on your notes, you can go and cross it out. We don't do pentagons. But it says find the indicated measure. Basically, we're going to use the volume formula, which equals area of the base times the height. We're going to use this to find a missing measure. So find the indicated measure. We're going to find the height. So guess what we're missing? The height. Of a cylinder, with a base radius of 8 inches and a volume of 2010 cubic inches. So the volume is 2010. And then we need to plug in the area of the base so we can find the missing value, which is the height. So area of the base, this is a cylinder, so the base is a circle. So the area of a circle is pi r squared. So we're going to plug in the radius so that we can plug in the area of the base. So 8 squared, which is 64. So 64 times pi is 201.062. So if you look, the area of the base is multiplying times the height. So the opposite of that is dividing. So the height is being multiplied by 201.062. We're going to divide both sides by 201.062. So all that is left on the right side is the height, and when we divide that, you get 9.9969, which is really going to round up to 9.99. We could say 7 even. But if I were rounding to the hundredths place, the 7 would make the 9. So this is 99. It would make it round up to, this would round up to a 10, and it would be inches. Last slide, or last problem, I promise. So sorry. It is volume of similar solids. So if you remember, similar means same shape, different sizes, same shape, different sizes. So there is a relationship between the volume and the similar solids. So it's going to look, we did something similar to this with area, and it's side 1 over side 2 cubed, because remember, volume is cubed. So this is going to be the only difference between this formula and the one we've already learned. The one we already learned about area, this was squared, because it was area, and area is squared. The volume is cubed. So, the side from the first shape, it is 3. They gave you the radius, so 3. Then they gave you the radius in the second shape, which is 6. I told you that you could reduce this fraction. Sometimes we chose not to. It is solely up to you. But 3/6 reduces to 1/2. So you can reduce. Again, it was 3/6, but that reduces into 1/2. And then it equals the volume of the first. So here is the volume, and the most common mistake is that students try to multiply 45 and pi together. You're not going to want to do that. If it's already written in pi, leave it in pi, because the second volume is going to be beautifully written in pi also. So leave it, and I'll show you how to kind of navigate through the problem with the pi, but leave the pi alone. We're going to cube, so whenever you're cubing a fraction, it's the same thing as multiplying it times itself 3 times. So you would multiply the top. 1 times 1 times 1 is 1. Oops. Sorry, the bottom number is a 2, not a 3. 2, 2, 2. 2 times 2 is 4. Times 2 is 8. And this still equals 45 pi. I left this blank. Do we know the volume of the second shape? We don't. That's the whole goal. So you could write V for volume, or you could write X, doesn't really matter. Then you have one fraction equal to another. You can always cross multiply. 1 times V is V. And then, when you go across the other side, 8 times 45 pi. You're actually just going to multiply 8 and 45. Because remember, I told you to leave the pi. So 8 times 45 is 360, and then pi. Okay, if you had a scientific calculator and you typed this in, it would tell you 36 pi. Since this is volume, it is centimeters cubed. If you need help, please come to a Zoom help class. I send them out in my email every week, and we can do as many problems as you want. These are all the area formulas. Write them down if you need them, and please reach out if you would like more help, more assistance, or more practice.